Welcome back to part 2, partial fractions.
That's what I was going to say, part 2. All right.
Oh, man. Why do we hate ourselves?
Listen, this is not as bad as it could be. So I'm going to tell you how my students want to split this up.
So teach me how to correctly do partial fractions. Let's see it.
So mine would say, all right, this is factored, so I want to split it up into x minus 3 and x minus 3, and they want to throw in their a and b like that.
Well, what's wrong with that?
Yeah, what is wrong with that? Well, if I left it like this, let's just pretend I did. These are common denominators already, so I can make that one fraction already. Oop, I'm just throwing all the wrong
I'm
things
already
in here.
lost.
Me too. So they're already common denominators, so when I go to combine this fraction, it is just going to be a plus b over x minus 3. But
which is just a number. A plus b. It's just a number, so that'd be like c.
Honestly, I didn't even think about that. I just thought, hey,
you don't have x minus 3 squared, so that is very wrong.
Right. So this is my common denominator here.
This is when we just quit. Ask chat. Ask snap.
So I need to figure out what I have to do to maintain that x minus 3 squared as the common denominator. Is there a way I can move this over, like, to the left?
You can...
How did you...
You do the little lasso thing here, and you slide it over a little bit.
Okay.
Yeah.
Very nice. Okay, so one of them could be x minus 3. But then the other one is going to have to be x minus 3 squared to be able to keep the common denominator being that x minus 3 squared.
Okay, I see.
And then I can still do my a and my b.
All right.
And then we can just do the process again. So, multiply both sides by the common denominator.
Right.
So my left side is going to stay 2x plus 5. And then the right side, this fraction here...
It's going to have an x minus 3.
Yep. One of the factors is going to cancel out.
Yeah.
But I still need the other. And
that one's just going to be b.
Exactly.
Does that mean you already know... Actually, no, never mind. It does not mean you already know b because you have a constant here too.
So...
But we do know another one. We know a already. Sorry, I'm jumping ahead.
You do. I have to go through my whole process, and I have to go.
I'm sorry. I'm here to learn. Let's hear it. Plug in that 3, right?
Oh, see, to me, why do you say you already know a?
Because it's the only x term. A times x.
Gotcha. Okay. See, I was gonna go backwards and say we already know b, but we don't. Anyway.
I was about to say that too.
Okay, so I'm going to plug in 3 so that I can cancel that out. So let's see, 2 and 3 make 6, 6 and 5 is 11. A cancels out, so I'm just left with B.
Nice.
Wow,
nice.
So B is 11.
I don't know why 2 times 3 processed in my brain as like 15. I don't even know why.
I don't know what to tell you either.
I'm in trouble.
But let's see what happens here because, oh my gosh, I cannot plug something in here, right? To like cancel it out.
Right. So you can just do something else.
I thought you were going to spoil it.
No.
We can plug in anything because to solve an equation, you just need one unknown. So I'm going to pick anything. I'm going to pick 0.
That is such a nice value to use.
But I still have an A and a B. But guess what?
You already know A.
Well, not yet.
I meant the other way around. You already know B.
You know A. I already know B, so I can plug that in. So 0 times 2 is 0 plus 5 is 5. 0 minus 3 is negative 3, so negative 3A. And then I have 11. So then, all right, just solve for what we don't know. Subtract 11. 6, negative 6. So, A is what, 2?
Yes.
Ta-da!
So
Now let's go back to how the heck you would have done
how I would have done it?
Yeah, because you said you knew what it was, but I didn't even plug in any numbers. You said, "Oh, I already know." You can erase all my stuff.
It's okay. I'll just open up a new page if it'll let me. There we go. All right. So you had it was 2x plus 5, and then a times x minus 3.
Yeah,
it was a 3, right?
Yeah, plus b.
All right. Well, if you distribute, so if you do it my way, you would distribute.
This one's a little easier, I think.
This is an a. There we go. Yeah, this one. This one's not too bad doing it my way.
Nah.
So this right here, these make up your constant term. Yep. And then this is your linear term. So you would compare these to the other side.
Right.
So you know 2x has to be equal to ax. So the a
right.
has to be the 2. And if you already know that, then you know negative 3 times a plus b has to equal the 5.
Right.
And and we already know that. And 3 times 2 is 6. Add that over, b is 11.
Yeah. So that was a little faster.
So I think the lesson to learn here is that the best way to do partial fractions is a combination of ways. Know them all.
All right.
What about quadratic factors?
Okay.
That's
like
another...
irreducible ones?
Yeah.
Prime ones?
Yeah, or prime ones. You mean like
x squared plus 4?
Yeah, but don't you even do them with like x squared minus 3?
Isn't that the same thing? Prime ones?
Well, that would be like x plus root 3, x minus root 3 if you factor it as a difference of squares.
Ooh, see, I don't do that.
Well, see, you don't have to. You don't have to.
Okay, let's do it.
I'm not good at... Okay, let's do it. Let's see. So the problem is going to be x squared minus 14 all over x to the 4th minus 7x squared plus 10. And that is a terrible addition symbol there. Oh, it wasn't an addition symbol. It was a minus.
And it's 14, not 4.
Oh, that was the issue. Copying is a skill.
Yeah.
Okay, so if you're trying to do partial fractions on this, you need to factor that denominator.
Yeah.
And if you don't know how to factor something like this, let us know, because we can make a video on how to factor higher degree polynomials.
Exactly.
So this is going to be x squared, so it'll be 5 and 2, x squared minus 5, and then x squared minus 2.
Yep.
Okay. Now, I'll tell you what I would have initially done. I would have done x plus root 5,
really?
X minus root 5, and then x plus root 2, x minus root 2. So all of those are, so you'd have 4 linear factors. Yeah, and they're all distinct, so you could do your little trick by plugging in the like root 5, negative root 5, root 2, negative root 2. However, this is more work that needs to be done, because apparently you can just do them with the x squared minus 2 and the x squared minus 5.
Yes.
At least that's what I've seen.
Yeah.
So,
okay.
So like, how would you do this one? Like before I even showed you this factoring, how would you do this one?
I would have just taken both those two things that we factored and made it x squared minus 5 and then x squared minus 2, and then up top it would be ax plus b and cx plus d.
And the reason for that is because you want it to be a proper rational expression where the degree of the polynomial in the numerator is smaller than the degree of the polynomial in the denominator.
To be honest and say I didn't know that was why.
Because that's the whole point, is you're trying to break it down into simpler, proper rational expressions. And so if you start out with one that's not proper, like if you had a cubic divided by a quadratic, you would need to do long division first, and then you would proceed with it, because your remainder from the long division would become a proper rational expression.
Okay.
Yep.
Makes sense.
And again, in the ax plus b, that captures all possible proper rational expressions we could have. So if a happens to be 0, so be it. That's fine. You would still have b over that one. You might get values for both of them. You might get b as 0 and just have the a term. So this captures all the possibilities.
Gotcha.
At least that's what I've always told myself. All right, so I want to see you proceed from here.
Okay, I'll tell you this one. I know I do with a system.
Oh, you do it with a system?
Because I start off doing my method, but then I don't look at it as, all right, what can I plug in to cancel out a term? Because I look at the x squared minus 2 and the x squared plus 5.
So you're a traitor to yourself.
Yes, 100%. 100%. But I guess you could do it because you could plug in the square root of 5
right.
and the square root of 2.
Right.
So here, I'll set it up. And
so
then
let's
we'll
do it. Let's do it your way. Let's do a combination of what I talked about and how you do it.
So let's just go ahead and pretend we have multiplied both sides by the common denominator. So I'm left with x squared minus 14 equals ax plus b times what was missing. So the x squared minus 2 plus cx plus d times the x squared minus 5, and I ran out of room.
That's okay.
So then, I guess,
and it's going to work nice plugging it in over here, too.
Yeah, because it's going to square.
It's going to square, and then the only place it's going to be a little different is here, but I bet what'll happen is you'll end up having the same value, like opposite signs, like with the you'll end up getting a little bit of a system, and then you can just add them together.
Okay. So let's see if we're going to try my method and knocking one out to make that be 0, right?
You need to plug in a square root
of 2. Everywhere there's an x.
Yep.
So square root, let's see, what's that? 2 minus 14?
Mm-hmm. Minus 12.
So, yep. This is going to go to 0, which means that's going to be 0 as well.
Right.
And then we'll have the square root of 2x plus d times...
I forgot your c, I think. Square root of 2c.
Oh, instead of x.
Yep.
Whoopsie-deeps. Okay. C times...
Do you not have the eraser button on your pen?
I don't think so. I have a button.
Yeah, if you hold it, it should be an eraser. Like, hold the button and then swipe.
Okay, let's see.
Just like erase that strip.
Huh? I literally have never done that. Okay.
How long have you had this pen?
Too
long. Longer than you want to admit?
I bought this tablet with this pen in 2020. So 5 years.
Never knew I could do that.
Nope. And what number is this? -3.
Okay. So you have...
I'm going to clean this up a little bit.
Yep. Oh, you could just divide both sides by -3, so you just...
Oh, even better. That's so smart. Okay, yeah. That makes things a little bit easier, because what is that, 4?
Positive 4 equals root 2c plus d.
Yep. You put it in the front, and I guess that's okay.
Yeah, that's where I always put the constants in the front.
And then we would have to do something.
So now you need to plug in negative root 2. Because that would also make it 0. And then you'll end up getting another equation.
Okay. Negative root 2. Interesting. I wouldn't have thought to plug in the negative one as well, to be honest. Such a bad mathematician. Okay. So then what do we get then? So that's what, -16? No, because
no, it's still the -12. It's still the -12.
I don't know what that was.
It looks like a B.
I think I was trying to do
that kid
both
ran
at the
away
same
from his
time.
dad.
Okay, so then that just changes this, right? So negative root 2c.
Yep.
Plus d.
And then all that times
still times the -3.
Yeah, so it should be
really,
4 equals.
Yeah, go a couple steps ahead. Okay.
Okay.
And then
so
we just
now
add them together.
Right. And so you get.
Okay, because this is our own little system.
And those are
eliminations.
opposite signs. Yeah.
So D is 8.
Ooh.
Okay. 8. Okay. And then I'm going to erase this. Everything I've done. All of my good hard work. To do the other one, to knock it out. Oh, shoot. I should have found C because we had our system there.
Okay,
So
well,
I
it's
should've found
4
C.
equals square root of 2c plus d.
Wait. It was what?
4
equals square root of 2c plus d. And then we know that d is 8. Right?
Yep.
Okay.
We're going to get a radical answer. Because you'll have to divide by square root of 2.
All right, we figured out an error we had, so we're going to pretend that didn't happen. You might have caught it before we did. What did we have? Our system was what? It was,
when we add the equations together, you're supposed to get A equals 2D, so D is 4.
Is 4, not 8.
And now that's going to make finishing this problem a little easier.
So 4.
Yeah. There we go.
So then if we back up to whatever...
So it was 4 equals square root of 2c plus d. Well, d is 4.
Yep. So 4 equals square root of 2c plus 4.
So c has to be 0.
Yeah. So if I subtract 4 on both sides, I get 0 equals square root of 2c. C would have to be 0. All right.
All right, we found two of the unknowns.
Now we can do it again.
Now you can plug in the root plus and minus root 5.
Exactly.
So I bet the same thing's going to happen.
Probably. So this one's going to cancel out, so I'm not going to worry about it.
Right.
So
root 5. 5 minus 14 be negative 9.
Negative 9. And then what is that?
Root 5.
Root 5a.
A plus
b times
5 minus 2 is 3.
All right, and then we can divide both sides by 3.
Yep.
So what is
negative
that?
3.
Negative 3 is negative root 5a plus b. So then the other one would be the same with the negative.
Right.
So negative 3, negative root 5a plus b.
Yep.
So then when we add these, I think I can add correctly this time. Negative 6
equals 2b.
Equals 2b, which makes b, was that negative 3?
Mm-hmm.
Negative 3. And then I can solve one of these.
Yep, and I would take maybe this equation.
This one?
Yep.
B is negative 3. Oh my gosh, that was ugly. Then I would add 3 and get 0 and get the same thing. So A is also 0.
So let's write our answer much nicer. Let's write it much cleaner.
So we get negative 3 over x squared minus 5 plus 4 over x squared minus 2.
Yep.
Cool.
What do you think about that?
That's kind of crazy because I only like using nice numbers, and square roots of numbers that are not perfect squares stress me out. So that was kind of cool that my method still works.
It does. It does.
Weird process.
You know, and I think you can stop there with the x squared minus 5, x squared minus 2, because if you were to factor those, they factor into irrational numbers. So, like, I think that's why you could stop there and just set it up as like 2 irreducible quadratics.
Oh, okay.
I think that's what I'm going to tell myself so I can sleep at night.
Alrighty.
Well, the only other scenario is doing the irreducible quadratic factors, where you have like x squared plus 4. But
okay.
Yeah, that's the
that
only.
That could be a part 3.
Yeah, let's do a part 3 on that one.
Alrighty.
This one's already long enough. My attention span's not that long.
Alrighty. Submit your problems. You know the deal.
We're still bored. Send us problems.
See you next time.
Thanks for watching.